Hello, my name is Hansa. I'm a graduate student in Neuroscience program in Istanbul Medipol University, and today I'm here to share about our work. Let me share my screen, please. Okay. tDCS improves empathic abilities and is associated with increased alpha activity in healthy volunteers. So what is empathy? Empathy is social ability to understand and share the feelings of others. And it's also described as affect transfer over distance. And it's combined ability to interpret the emotional states of others and experience resulted related emotions. And there's affect. So what is affect? Affect is the collective term for describing feeling states such as emotions, moods, and it's the outward expression of feelings and emotion. And it's described as mental counterpart of internal bodily representations associated with emotions by Barrett and Bluis-Morrow. In one study containing empathy and they used neuroimaging, they found out that temporoparietal junction, anterior medial prefrontal cortex, and inferior frontal gyrus is associated with mental representation of the self and the other, and also perspective taking by tDCS et al. And temporoparietal junction is known to be the key node for functions known as the social brain. It's related to higher social cognitive functions such as empathy and mentalization, and also lower social cognitive functions such as discrimination and perspective taking. In one study by tDCS and others, they found out that anodal stimulation of TPJ resulted in increased cognitive ability skills, whereas cathodal stimulation of TPJ resulted in disruption in the ability to leak into the mental and emotional states of others. So actually, the cathodal stimulation of TPJ decreased empathic abilities. Anterior medial prefrontal cortex is related to egocentrism, and Boggio and Bertozzi found out that cathodal stimulation of AMPFC resulted in decreased egocentrism and increased other directedness. And inferior frontal gyrus, IFG, is known to be responsible for perspective taking, emotional empathy, shared mental representations, and the extent in which they are perceived subjectively, and neuroneurons. And anodal stimulation of IFG resulted in increased empathic abilities also. So, based on the previous studies done with fMRI and tDCS, we hypothesized that the empathic abilities might be increased by tDCS with the protocol we designed, in which the anodal stimulation of RTPJ and cathodal stimulation of AMPFC is being done simultaneously in just one protocol. So our purpose was to examine the functional connectivity of stimulated RTPJ and AMPFC regions with IFG and frontal regions, based on the studies done with fMRI, in which IFG and frontal cortex are associated with empathic processes. And another purpose was to contribute to the literature in terms of brain regions that are associated with empathic processes and how tDCS can or might alter or modify emotion recognition and spontaneous EEG activity in healthy participants. So this was a randomized and controlled study in line with the Declaration of Helsinki, and it was approved by the Invasive Clinical Research Ethics Committee of Istanbul Medipol University. It's carried out at Alaaddin Keykubat University Training and Research Hospital in Antalya, Turkey, and it was with the collaboration of Istanbul Medipol University, Department of Neurology and Cognitive Neuroscience. The study started on March to July 2023, but it's still going on, so it's still going on research. The total of 34 healthy participants were included in the study, STIM group being 17 healthy participants, sham group being 17 healthy participants again. Their mean age was 22, and resting EEG recordings both before and after the tDCS procedure were carried on, and EEG analysis was made on a subgroup of participants, STIM group being 7 participants and sham group being 4 participants, since it's a preliminary study. So our inclusion criteria was participants providing informed consent and being literate and being between 20 to 25 years of age, having no psychiatric or neurological disorder, not using any medication that would affect cognition, memory, and affective state, having a score of higher than 21 from MoCA so that they would be healthy participants, and having a general symptom mean lower than 0.5 from SCL-90. So our exclusion criteria included illiteracy or educated lower than primary school level, and presence of an existing or previous neurological or psychiatric disease or head trauma, and or irreversible hearing or vision problems or other medical illness such as depression, personality disorders, psychiatric disorders, and autism, etc. And also, of course, presence of medical issues that would prevent the application of EEG or tDCS. So first, we recruited participants by administration of MoCA and SCL-90. So we included our participants according to these results. And then we did a neurocognitive assessment, including RMET and BES. And then we did a spontaneous EEG recording, resting state. Then we applied tDCS, and then spontaneous EEG recording within 2 hours after tDCS, and also again neurocognitive assessment, administration of RMET and BES within 2 hours after tDCS. So neurocognitive measurements included reading the mind in the eyes test and basic empathy scale. It was a Likert type self-evaluated, and they were applied both before and within 2 hours after the tDCS procedure. EEG recording was made both before and after the tDCS procedure. It was recorded from 21 channels according to the standard international 1020 system, both eyes open and eyes closed conditions, with using a Neurofax Nihon device, which is Japan-based. So our tDCS protocol started with the measurement of enion and nasion, and then putting anode over RTPJ, which corresponds to CP6 point in 1020 standard international EEG system, and cathode over AMPFC, which corresponds to a little bit left to the FPZ region. And then the density was 1.5 milliampere. There was active stimulation for a STIM group, and there was no stimulation for sham group. Actually, there was a little bit of a feeling that the electricity was coming through their scalp, but it was stopped after like maybe 15 seconds so that it wouldn't affect the electrical activity of the brain, but it would make the participants think that they're actually receiving a real treatment, let's say. The randomization process was made by a NeuroMars device stimulator, and it was not possible to distinguish STIM or sham. And here are the current densities of the electrodes. So for EEG analysis, we did a power spectral analysis, and we checked the peak amplitude of frequency bands, alpha band especially. EEG analysis was made on a subgroup of participants, as we said before, since it's a preliminary study. And we had 8 parameters for EEG. For active stimulation group, there was before procedure, eyes open, eyes closed, and after procedure, eyes open, eyes closed. And also sham group, we have before procedure, eyes open, eyes closed, and after procedure, eyes open, eyes closed also. So statistical analysis was made with SPSS 22.0 for Windows, and we used non-parametric tests. We used the Wilcoxon signed rank test for within groups and Mann-Whitney U test for between groups. So for results, our demographic data, as you can see, the mean age was around 22, and education level was 14 years of education, which corresponds to, they were all university students. And gender, we included 36. Males were 12 and females were 24. And for sham group, there found to be no statistically significant difference in any of the Wilcoxon rank tests. And for active stimulation group, for eyes closed condition, the difference between maximum alpha amplitudes before tDCS and after tDCS in C3, C4, F8, and T3 electrodes was statistically significant. And for also active stimulation group again, after tDCS, the difference between maximum alpha amplitudes for eyes open and eyes closed condition was statistically significant for F4, P3, O1, O2, F8, T3, T5, T6, FZ, and PZ, and T2 electrodes. And also before tDCS, the difference between maximum alpha amplitudes for eyes open and eyes closed condition was statistically significant in P4, O2, T5, T6, and PZ electrodes. For eyes open condition, there found to be no statistically significant difference in alpha peaks between before procedure and after procedure in any of the electrodes. And when we compared differences between two groups, real and sham groups, there found to be no statistically significant difference between two groups in terms of condition, being eyes open before and after tDCS and eyes closed before and after tDCS for all of the electrodes. And for this analysis, Mann-Whitney U test was used. In a study done with 4-year-old children, regional current density estimates of preschoolers' resting EEG alpha was used for showing that individual differences in EEG alpha activity localized to dorsal MPFC and RTPJ were positively associated with children's empathic skills. So this study was done, that study was done on children, but we wanted to see the effects of adults, let's say, and we applied our study on adults. And both the excitability of RTPJ as well as the inhibitory stimulation of AMPFC seem to be related to increased emotion recognition abilities, which points out that emotion recognition is a complex process requiring the integration of different cortical areas in a coherent way. So, the findings of this study is promising as they demonstrate significant electrophysiological changes in brain regions relevant to the targeted areas by tDCS and also with the alpha frequency band that are associated with empathy. Thank you for listening to us.